In today's video tutorial, I'm going to teach you how to convert the octal numbers to other bases such as the binary number system, the hexadecimal number system, and the decimal number system, or simply converting octal to binary, hexadecimal, and decimal. So say for example, we are given the octal number 27. Now, before converting any number to octal, see to it that the number that we are converting falls under the range between 0 to 7. So, because that is the lead digits of octal numbers. So, 27 is valid. So, we can convert this to other bases. Now, we have here the octal number 27. So, to convert it, we are going to convert it first to binary. So, we do this by... So how we're going to represent this 7 into a binary digit. So using the positional value, we know that 7 is a full 1, 3 digits. So we have 1, 1, 1. So this is the binary representation of 7. Since we know that each octal digit is equivalent to 3 binary digits. So 2 is represented by 0 and 1. Okay, so this is the representation of that, and this is this one. So we don't put any more 0 here since it is on the left. So you only have 1 0 1 1 1. So this is now the binary equivalent of 27. Okay, now that we have already the binary equivalent, we can easily get the hexadecimal equivalent. Again, we write the binary equivalent, and then we count 1 2 3 4, and then we follow the positional value 1 2 4 8 and 1. So we add the values which has 1. This is 7, this is 1. So 27, which is 10111 in binary, is 17 in hexadecimal. To convert it to decimal, let us use the hexadecimal equivalent. So we have 17. Since that is in hexa, that is times 16 raised to 0 times 16 raised to 1. So we have here 7, and then 16 times 1 is 16. So the decimal equivalent is 23. If you want to use the octal equivalent, we can also have that. You can also use that number to convert it to decimal. So you multiply it by exponent of 8. So we have 8 raised to 0 is 1 times 7 is 7. 8 times 1 is 8. 8 raised to 1 is 8 times 2. We have 16. So if you can see, we still get the same decimal equivalent. So let's have another example of an octal number being converted to binary, hexadecimal, and decimal. Say we are given the number 326 in octal. How are we going to convert it to other bases? So again, we start converting the numbers to its binary equivalent. So we start with the last digit 6. So how do we represent 6 in a 3-digit binary number? So using the positional value, 6 is 0 1 1. So this is the binary equivalent of 6. 2 is 0 1 0, and 3 is 1 1. So 0 is at the left, so we disregard the 0. So we have 3. So this is now the binary equivalent of 326 110 10 110. Now that we have computed the binary equivalent, we can easily get the hexadecimal equivalent. So how? We simply rewrite the numbers or its binary equivalent, and then we group it into 4. 1 2 3 4 1 2 3 4. So using the positional value, this is 6. This is 1 plus 4 plus 8, that is 13. But 13 is D in hexadecimal. So the hexadecimal equivalent is D6. to convert that to convert it to decimal, to convert it to decimal, we can use the hexadecimal, the given octal, or the binary equivalent. So let's use this hexadecimal. So d6 times 16 raised to 0 times 16 raised to 1. So we have 16. This is 1 times 6, that is 6. 16 times 13 is 208. So the decimal equivalent is 214. So that is if we use the hexadecimal equivalent. Now if we use the octal number, the given octal number, let us check if we will get the same decimal equivalent. So we have here 8 raised to 0 is 1 times 6 is 6. 8 raised to 1 is 8 times 2 is 16. 8 squared is 64 times 3. We have 192. So adding this will give us the same 214 as its decimal equivalent.